a deriving force, deriving the triangle area formula, the law of sines and the law of cosines. That's our focus. Our two key terms for this lesson are going to be the law of sines. What is that? And the law of cosines, which, by the way, hint, hint, sines uses opposite sides, cosines uses adjacent sides. We're going to derive these formulas and then put them into practice. And everything about trig that we've explored so far of sine, cosine, tangent, we're going to use that knowledge to solve more complicated problems. Usually these are problems where the triangle is not a right triangle, but embedded in that triangle itself are right angles, and then we can use our knowledge about the law of sines and the law of cosines, and then the triangle area formula to answer problems, even if the triangle is not a right triangle. We're going to derive the formula for the area of a triangle using the sine function, which should be like notes and poster. We're going to derive the law of sines. We're going to derive the law of cosines. We're going to use trig ratios, the Pythagorean theorem, the law of sines, and the law of cosines to solve problems involving right triangles and other triangles. These are the final four that you need to know. Let's review. Here we have solve for x in each right triangle. And in the first method, because I know two sides and I don't know the third, I'm going to use the Pythagorean theorem. See, this is what you have to do. You have to dip into your math toolbox and pull out the tool that you need to use to solve this problem. You got to know why that tool is appropriate. In question 1, the Pythagorean theorem is appropriate because we know two sides, we don't know a third, and we don't know any of the angles. Trig isn't necessarily appropriate, although possible. We could get to there through a trig method. This is more direct. C is 18. Let's say it goes A, then B, then C. So x is A is squared, so x is squared. 10 is B, and 18 is C. Then we got to do some like simplification, so 18 squared minus 10 squared. I don't quite want to jump to the 18 squared. I think it's 324. I don't want to jump to 18 squared yet because I want to at least live in the smaller numbers that I'm writing before I write a bigger number. But x squared equals 18 squared minus 10 squared. Go another step. Square root everything. 18 squared, take away 10 squared, and we square root. So now I need to figure out, hey Siri, what's 18 squared? Hey Siri, what's 18 squared?
18 squared is 324.
Okay, so then 324 take away 10. Square root 224. If I take the square root of 224, one second. Where did it go? I need my board cleaners. This is one of my YouTube shorts. Check it out if you need to. If you haven't yet, posted for the work for this year, or dig through my content to find, or just search it up on the line. There's other great resources. But when you have 224 and you're square rooting that number, let me zoom in. There's something about how that is a large number that is possible to be divided by other perfect squares. And I noticed from my understanding about division of fours that I can divide this by 4. And if I can divide the last two numbers by 4, then I can divide the entire number by 4. So 4 times, hey Siri, what's 224 divided by 4?
224 divided by 4 is 56.
Yeah, okay. So that's square rooted and that's square rooted. Let me go one more step though. I know that I can divide 56 by 4 for reasons. So let's say this can be also broken up into 4 times 14. Square rooted, square rooted. This right here can't be divided by any more perfect squares. Perfect squares 1, 4, 9, 16, 25. We can't divide that by any of them. So this stops. But we know what the square root of 4 is. And we know what the other square root of 4 is. And we don't know what the square root of 14 is, so just leave it as the square root of 14. And then notice that you can do 2 times 2 because that's out in front. So 4 times square root 14. That's our exact answer for x. And if you need to know the decimal, just go to the calculator. It's time for the calculator. Question 2. Because I see the 36-degree angle, labeling that theta, HOA, it looks like AH is information that we have along with theta. We don't know the A, though, the adjacent side, but AH is cosine. So cosine of 36 equals x, the ratio of x and 20. It's in degrees. Make sure your device is in degree mode. Multiply both sides by 20. X equals 20 times cosine of 36 degrees. I'm honestly going to leave it like that. You can go do the calculator work with that. Now, last one. We have theta, HOA. We don't know the degrees, but we do know OH, which is sine. So SOHCAHTOA, sine is O over H. So therefore we have sine inverse of 7 over 12. That's going to be what x degrees equals. I took some time to show you how to do this because you need to understand how to break apart a larger number when it's being square rooted, reducing a square root. I'm not showing you how to do this because I already did. And I'm not showing you how to do this because I already did. You should be an expert at it. It is Spiral Review after all. Thank you so much for liking, commenting, and subscribing. Page 600 is next, where we're going to continue talking about area of triangles, law of sines, law of cosines. See you in the next episode.